general part. I know everybody has PowerPoint poisoning by now, so I know how it is. So maybe we can briefly have all the presenters come up, Jan-Lin and John, and maybe talk a little bit about more general questions. Essentially, what is the purpose of software attestation? Do people buy the story in general? It certainly, as we've heard, there's a lot of issues with remote verification. The technology certainly isn't valid for every case, but I hope we've convinced you that there's some cases where it is valuable. And maybe we could discuss some of these issues right now. And if people have more general questions, so that we can address them now. Maybe there's one.
All of these rely on your ability to get an optimal algorithm implementation, right? That you know how it behaves on, well, not yours, but some of the other ones, right? You need to know how well the algorithm will perform on the platform, right? But given the fact that the platform is actually made up of very heterogeneous hardware components, some of them which may perform better than other components, you don't necessarily know that your algorithm ran on that core or some other core, like a virtual, right? Like a graphics core, for example. So how do you get the confidence that you ran on the right core and you're getting from the right component of the system?
Right. Actually, you need to check the fastest core first. And ideally, actually, in many cases, even if the core is slower, it may have some hardware properties that will make the code fastest to run on that core. But in any case, in general, you will run it first on the fastest core. And once you've established a root of trust, you then use that core to check the others.
So you would have to use graphics core first, then, probably.
Well, there are some operations which the graphics core probably is not as fast as the other ones. And the algorithm is usually constructed in a way that you can't parallelize it. So then we had a project here called Pioneer where we did implement this for a Pentium 4 processors. And there we specifically designed it to maximize the use of all the components of the processor at any moment in time. So since graphics cores are quite different in structure, it would actually take longer to execute, I'm pretty sure. But if, of course, since graphics cores are extremely parallel, 48 or a lot more parallel units, so you can also design a software station on that where all the units run concurrently, all the results are combined at the end. So it's possibly the way to go. It's an interesting question. Are there other comments? I think we only have actually one microphone, but that one is the one that's connected to the camera. So maybe you can have that one around, John. Look,
Now, I guess I just wanted to, I think you've just drawn attention to what's one of the big open questions, which is how do you design the verification function such that it's optimal for the hardware where it's going to run. And the optimal design for a graphics core and the optimal design for a Core 2 Duo are probably pretty different. And how you can say that one will definitively outperform the other is I think, a question that we need to find an answer for.
Other questions?
So is there a danger with checking the fastest core first? Checking the fastest core first is a clever solution, but is there a danger of malware migrating from a slower core to a fastest core after you check the fastest core?
So that's also a very good question. So what we do is we build up what we call an untampered execution environment, and that's very similar to dynamic root of trust that isolates the memory from any other components. And so you need to have also a core that allows you these properties. For example, there's a, I believe it's called AGP aperture, that allows you to isolate part of the graphics memory from any other components. And so that would be one way to utilize graphics memory. Sorry?
You would need this for every single core, but the slowest.
No, only for the fastest one. And once you have the fastest one, well, you're right in the sense that.
If it migrates from the slowest one to the second slowest one.
Right. No, you're right. But usually you have memory. You can program the DMA controller and through exclusion vectors to isolate the memory that you have verified. And so once you've verified the fastest core, that piece allows you to isolate the memory, then you can keep checking core by core and keep isolating the components so that at the end you've checked your entire system. But in general, you need to give me a very specific. I mean, these systems are very complicated to design. That's one of the disadvantages. But once you have a specific graphics processor with a all specific components, you then need to very carefully design it to make sure that such migration cannot happen anymore. But it's very tricky. I agree.
You guys give any thought to scalability and what would be necessary if industry decided to do this tomorrow and all of these other details were ironed out? Have you given any thought to how do you make a scalable solution?
What do you mean by scalable?
So all of except for the malware portion, it requires you to have intimate knowledge of the hardware and every piece of the hardware. So if you look at just a modern PC right now, you have multiple components that are all completely, they all work with one another, but they're all very different. They change regularly.
I'm not sure if I should take all the questions.
Is this question for one of you guys? I mean, I can add a little bit. I don't know if this directly addresses the question that you just asked, but I mean, it's also software-based attestation, right? We've already talked about a lot of the challenges that just face attestation, and so at some point we've said, okay, yeah, now we've got this attestation mechanism that doesn't require hardware support, but we still run into the problems that attestation faces, and knowing what is supposed to be there, trying to construct some kind of whitelist or infer the result of these measurements. You may be able to create this isolated execution environment, but that once you have it, you have to do something useful with the thing. You have to architect software to either do your useful work immediately upon getting the property that you're happy with the environment. You eventually kind of degrade back to the state of an unwieldy large system that we face just in general today. I don't know that directly addressed the question that you asked.